Hello everybody in the 311 Programming Language Concepts course at CSU East Bay. This video, as promised, is going to go over assignment number 6. Assignment number 6 is on chapter 5 of the textbook. So this is the week, the 13th week of class. We are getting towards the end. We have 2 weeks left, so you do want to start turning in those outstanding assignments if you're behind a little bit. By the end of this video, you should be able to turn in assignment number 6, no problem. I will also do the same thing for assignment number 7, but I'm not going to do it till next week. So next week, we'll go over assignment number 7. This week, I'm going to talk about assignment number 6. I'm giving you a lot of time this week to catch up on assignments. The lectures are going to be kind of minimal, so that you have enough time. I do want you to finish all of these assignments on time because I will not accept any assignments past 5/6. That's May 6th, which is coming up very shortly. We are in the 13th week of class. We have 2 weeks, well, about 3 weeks if you count this week, plus the final exam week. So about 4 weeks, 3 or 4 weeks here. So we are getting towards the end here. I will have more information on the final exam as we get a little closer. This week, however, is only the 13th week, so I'm going to cover assignment number 6. So assignment number 6 is pretty basic, actually. You're answering 5 questions after reading chapter 5, which is on names, bindings, type checkings, and scope. But the questions are kind of tricky. So hopefully you've attempted this assignment on your own. I'm not going to write the answers. I'm going to talk about the answers. And so you need to formulate your own answer. You can use the answers I'm giving you in this video if you'd like. So pull out the assignment, take some notes, or stop the video, pull out the assignments, take some notes, because you are going to want to use this information because it's going to help you. And I'm going to explain the questions and explain the answers because the questions are kind of tricky. So, for example, number 1, some programming languages are typeless. What are the obvious advantages and disadvantages of having no types in a language? Now, I kind of talked about this question in the last video, so I won't elaborate too much. But we know about this question, some of you should be able to answer this question just fine from the midterm material that I gave you so far. Because if we talk, and we can compare languages when we do this. If we compare Python, for example, with C, Python doesn't require you to write in types, but it does have types. So Python is not a typeless language. C is a language that is not typeless as well, but C has you explicitly write the types, while Python implicitly writes the types. So what is the type? The data type is the amount of memory that's pre-configured or dynamically configured to store the variables. So if you don't have types, how do you know how much memory you're supposed to store the value for the variable? So the typeless languages are the earlier languages, like way early, or the scripting languages, like JavaScript. Actually, in JavaScript, everything's a string by default. Python, don't be confused, does have types. It does use types. But there aren't too many languages that are typeless these days, not modern languages. These would be older, mostly scripting languages from the past didn't have types. So that's because you have tons of advantages to having those types. Now, it's not having anything to do with the programming, so take your programmer hat off and put on your language design hat because we're talking about the design of the language. So what are some obvious advantages and disadvantages of having no types in the language? Well, okay, let's talk about the disadvantages first, and then I'll talk about the advantages. So the disadvantages of not having types. The disadvantage is that you don't know ahead of time how much memory you need. So how do you know if your memory is going to expand past what you've allocated? So it makes memory allocation extremely confusing. If I don't know I'm going to put an int value in there versus a double versus a float, I'm probably going to over-allocate. So in general, a disadvantage is that it's wasteful when it comes to memory. You can't conserve the memory because you have to reserve a space to hold the variable or to hold the data that you're thinking about holding. You don't know what type it is. You don't know what value is going to be stored in that type, which means you don't know how big of a space you need. And so you're going to overallocate. So not having types in a programming language leads to overallocation and wasting memory. You're wasting memory because you are going to reserve more than you really need. And if you do that, you're, it's wasteful. You're probably not going to fill up the space. You have to, prepare for the worst. Reserve the biggest memory possible to store the small little float or the int or whatever it is you're going to stick in there. And then it says, what are the obvious? Well, just mention a couple. So one of them here would be it's wasteful when it comes to space. A second one would be that the time it takes to allocate the memory and the timing of it has to be dynamic. You can't do it statically, which means it's going to slow down the runtime. So yeah, not having types slows down the runtime of the program because you don't know what you got. You have to allocate the space dynamically at runtime. And remember, static happens before runtime, dynamic happens after the runtime starts. You have to allocate your space dynamically, and if you do that, then it's going to be very slow. So it reduced efficiency of the runtime, which could slow down how fast the program is actually running. So that's also another disadvantage of the type. I'm only going to give you two, but you could probably dream up more, and the book's got more actually as well. So what are some of the advantages? Well, you could say the opposite of what I just said a few minutes ago. It's more conservative on memory. You only need to reserve what you need. You already know what you're going to have. You're already going to know what you're going to store, so you already know how much memory you're going to need for it. It's going to be an int, it's going to be a float, it's going to be a double. So these predefined definitions allows you to conserve less memory, be more mindful with the conservation of the memory resources, and it's also faster because it can be determined statically. You don't have to wait until the program actually runs to do it dynamically. So you've got the opposites for the advantages of it. Now, for a disadvantage, for an advantage, some people might venture out into the programming world and think like a programmer. And if you're thinking like a programmer, one is not easier than the other, and don't write easier or more difficult for any answers to any questions on anything, because that's not relevant. The ease of programming doesn't mean anything. However, if you do have types, then the compiler is doing more for the programmer. The compiler is deciding on what these types are. And so when a programmer uses a type, they have a tool. It's kind of like if nobody invented the hammer and the carpenter had to invent this concept of a hammer before using a hammer, then it would take them longer. So it is easier for the programmer to use a type because it's predefined and it's a tool that's given to the programmer, like an array. Here's an array, use it. Here's a stack, here's a queue, here's a this, use it. And so it's easier for the programmer to actually use a type than it would be to have them invent the concept of the type ahead of time. So for the advantage, it's easier for the programmer, but don't write is easier. Write something like, provides built-in tools that the programmer can use instead of having to reinvent the concept on their own, which is a good one. Now, as for another advantage, if you have types, then you can do type checking. And type checking is going to check for errors with the data and the manipulation of the data, either before the program runs or after the program runs. Remember, we have static and dynamic type checking that can occur. So if we do have types, then we could do some type checking. And if we do type checking, then we can check for errors. And so it might make the program more reliable. So the advantages, more reliability, because we can make sure that the operations make sense and that the data is used correctly. Easier for the programmer because it's more automated and these types exist. They don't have to reinvent the wheel. And more efficient because we only reserve what we need. We don't have to overallocate. So there's a lot more advantages than there are disadvantages. But the disadvantages are pretty big. You know, if we're going to waste a lot of space and we're going to make the program run slower. So if you want to improve the quality of your programming language, you want to create types, because types are going to help. And don't be fooled with the differences between explicit and implicit typing. A language like Python, which does implicit typing, has types. There are types in that language. So it's very common on the internet, actually, for people to misunderstand that Python, just because you don't write int, doesn't mean that, you know, I is equal to 5, that you haven't created an int data type. You have, but it was done implicitly, not explicitly. So don't get explicit and implicit confused with types or no types. There are types in both languages. Python supports data types. Yes, it does. You just don't write them. Okay, moving on to number 2. Write a simple assignment expression with an arithmetic operator in some language you know. For each component of the statement, list the various bindings that are required to determine the semantics, and the statements when the statement is executed. For each binding, indicate the binding time used for the language. So let's just start out first by writing it. So write a simple assignment expression with one operator in some language you know. Okay, so an operator, arithmetic operator. Okay, so let's use the C language. Here's an assignment expression. So I'm going to say that integer I is equal to 5 plus a. All right, so there is my assignment expression. My cap locks are not doing me justice. There we go. I wanted to write that. I mean, my cap lock, my spell checker. This is Microsoft Word, so it got changed on me. So write a simple assignment statement. This is an assignment operator, assignment statement, with one arithmetic operator, that's the plus, in some language you know. Okay, so there's my statement. So you can write one yourself. You can use this one or you can use a different one. I don't really care. I'm pretty much giving you the answers to this assignment, so as long as you're watching the video and writing down and taking notes and understanding the material and writing your own answers on the document to give it to me, you pretty much could give me my answers back and you're going to get full credit. So don't worry about it. You can use what I'm writing in this program, in this video, excuse me. I'm giving you the answers. You can give me these answers back. It's proof that you watched the video. So I will give you credit for it. And I usually do this in class, and it's usually towards the end of the semester when I have a very low attendance. And so I give credit. This is sort of like your attendance credit. I give you attendance credit for actually listening to me. So for each component of the statement, we have 1, 2, 3, 4, 5, 6, 7 components of the statement. We don't have to worry about the semicolon, I guess. List the various bindings. Okay, so we have bindings. Bindings come in 2 forms. So bindings, if I had a whiteboard, I'd be writing this down. Bindings. Bindings can be static, dynamic. Bindings are also considered early, late, delayed. These are words used in Chapter 5 to describe bindings. So you got to pick your own measurement tool. So they all mean the same thing, really, because static is early, dynamic is late, and it's also called delayed because it's later than late. It's going to be delayed. So if you never use the variable, you never use the assignment, it never actually gets bound, then it will never actually be bound. It's delayed. So the delaying is a variation of late. Late means after what the runtime has started. Early means before the runtime. So the runtime is one of our times. So those are the bindings. And then we have binding times. Well, what are the binding times? Well, we have compile time, runtime, we have write time. If you go back to that lecture 5, you'll see all the times. Write time, language design time, which would come before language design time, write time, compile time, run time. Well, actually after compile time, we could have load time, link time, load time, link time. And you're probably wondering, like, where am I getting this stuff? Where is it coming from? Am I just dreaming this up? Well, actually what's going on here is I'm going through the chapter 5 by memory, and I'm writing down some various times. And so these times are coming from different ways that languages describe binding times. So a binding, let me just give you a definition here. A binding is an association. We're going to associate a concept with a process or with an algorithm. So for example, if I said linear search, that's a binding. We've bound the name linear search with the concept of using a link to go through an array, for example, and look at each item one by one. That's a linear search, which is not a very efficient search, but it's a linear search. It's a binding. So if I wanted to use a binding of a variable, for example, here's a binding. I have a declaration, which is a binding. This declaration integer I as a unit is a static binding. It's a static binding of I as a variable with a data type called int in the C language. So that we know from before the midterm. We've looked at this terminology before. And when did the binding happen? It happened at compile time. It happened at compile time because what we've got now is something that is done statically. Most of your static stuff happens at compile time. So a lot of these bindings here link up directly to binding times here. Anything delayed or late is going to happen at runtime or later than runtime. So where am I coming up with these times? Well, these times are language by language. No two programming languages use the same binding times, by the way. There's some similarities, and some of them use it in language design time. Some of them use it in write time, load time, run time. Like Java's got lots of the differences between the load time and the link time. C++ puts them together. So these are not a universal list. This is not the whole list either. These are the ones I'm going to use for this example. These they vary language by language, and I'm talking about the C language right now, not the C++ language or Java. I'm talking about C, and I wrote a C statement, and I'm going to use these times. Now you can go on the internet and look at binding times, and you'll find that you might have different lists. They're all going to be words describing. It's kind of like the stages of compilation. There's no one set stage of compilation out there. So, I mean, yeah, we have syntax and semantic analysis, and you have all the, the kind of, descriptive stages that people use to describe the process. But no two compilers use the same identical stages of compilation, just like no two programming languages are going to use the same binding times. Nor are they going to use the same, binding nature. Is it going to be static or dynamic, or is it going to be early, late, delayed? So, all right, so let's go back to the question. So for each component of the statements, list the various bindings that are required to determine the semantics when the statement is executed. I just did that for you for this one here. So integer I, that is a static binding. It's a static binding, so I'm not gonna write it underneath, but I'm just telling you, integer I is a static binding. It's a binding of a variable. It's of a data type to a variable, and the binding is happening at compile time. When we compile the program, we're going to make I, and it's going to be of integer data type. That's a static binding. So now that we have the next part here. This is an assignment expression. I is equal to 5. That's also a static binding. And that is also happening at compile time. Okay. And then we have, well, actually we had I is equal to 5 plus A. I'm just going piece by piece, but operator by operator. So then we have this operator here. We have 5 plus A. What's A? Uh-oh. We finally found something that's dynamic. So we don't know what A is going to be. So A is going to be a dynamic binding, because we have to go resolve A to find out what A is going to be. So it's going to be dynamic. And it's going to happen at compile time. Because, well, this here's the problem. This is the C language, and this is a C static variable. Everything in the language is static, which means everything in the language of C is compile time. So that's kind of a no-brainer. If we went through, and what I just did for a second ago is went through statement by, expression by expression. If we went through piece by piece, that's a data type. It's a data type. A data type in the C language is static, and it's compile time. I is the name of a variable. It's static. It's also compile time. That is language design time. Somebody put and created a symbol equals in the language and designed it to do assignment expression. That's an assignment expression. Versus a 2 equals, which is a comparison expression. That's also language design time. 5, language design time. Someone said you can use the integer values 1 through, whatever, plus, for the same reason why the equals, and everything in here is static, by the way. It's all static. The plus is also language design time. The A, that's an interesting question. It's compile time, not language design time, and it's static. Well, you could argue and say, no, you can't, actually. It's static. So that's the C one. Let's talk about Python. I'm going to do another expression in Python. You only have to do one. But let's just take a look here. So for each, let me answer the question and make sure I've got the rest of the question here. For each component of the statement, list the various bindings that are required to determine the semantics of the statement that is executed. When executed, well, in here, all of the bindings are done statically. The answer to that question is everything's static in C++. For each binding, indicate the binding time used for the language. You could say each one of these components has a binding to it, and you would just say for each one of the components, like I just did a few minutes ago, like int is language design time, I is, well, that's actually write time or compile time, depending upon how you want to do it. The equals is a built-in operator, language design. The 5, again, is compile time or write time or compile time. Plus built-in A, it's the same as I, so it's going to be write time or compile time, and they're all static. Now in Python, if I did this, if I said I is equal to hello, and this is my Python statement, I'll just leave it capitalized. I is dynamic now. So the binding is dynamic. It's not a static binding, it's a dynamic binding. And this is happening at runtime. So some people write runtime like that, and some people don't write it like that. It doesn't really matter which way. Runtime is really 2 words, but you'll see it put together. So I is runtime, and it's going to be dynamic. You could also say that it's late. I don't like to use the word early and late because early and late means static and dynamic. So you'll see in literature, you'll hardly see it anymore. It's kind of sort of being faded out. People will fade that part out. They're not going to use it. They'll just go static or dynamic. Earlier languages like to categorize their I don't know why I'm doing that. Categorize their timing, the bindings, and the characteristics of the timings differently. So, all right. So I is dynamic. It's dynamic, and it's at runtime. It's at runtime, and it's dynamic. This one here is still the same. It's language design time. Somebody invented this concept, and they put it in the language. And it's actually static. It's static because it's happening before runtime. It's at language design time. So on the scale of static versus dynamic, everything that happens before runtime, and runtime is the key here. Let me put that in bold. Everything that happens this way in the list is static, and everything that happens this way in the list is dynamic. So we know that from the midterm, I hope. So we have the assignment expression, that's language design time, and we have it equal to hello. Well, that is 100% dynamic. Dynamic, and you could say it's delayed, but it's dynamic, and it's at runtime. So the binding time is going to happen. We don't know what this I is going to have equal to it until we give it to it. So it's definitely runtime, and it's definitely dynamic. So I hope that's given you some ideas about how you're going to approach number 2. You can use my Python, you can use my C example, or you can write one of your own if you'd like and do another practice with it. So I'm going to move on to number 3. And number 3 is interesting. It says dynamic type binding is closely related to implicit heap dynamic variables. Explain this relationship. All right, so what's dynamic type binding? Binding the type at runtime. What's implicit heap dynamic variables? What is an implicit? Well, if you go back to that lecture 5 towards the end of it, you'll get an explanation of it by the PowerPoint. But let me just tell you, implicit, implicit versus explicit. Implicit's done by the compiler, not the programmer. Heap dynamic variable is in the heap memory address. So it's the heap allocating to the heap a variable. So an example of an implicit heap dynamic variable would be one that would be created by a copy constructor. So in C++, the copy constructor would create, if you put in the copy constructor a couple lines of code, because you know what a copy constructor does, I hope, in C++. If the object has allocated some memory, I'm going to explain right now what a copy constructor is. A copy constructor occurs when an object has allocated some memory and you perform an assignment expression. So you create, let's say, object number 1, and then you create a new reference for object number 2, and you want object number 2 to point to be copied, a copy of object number 1. Well, what ends up happening when you do the assignment expression for the second reference is that both objects are going to be pointed to the same implicit heap dynamic variable or memory that is created. And now what ends up happening is if you don't write a copy constructor, both objects are pointing to the same piece of memory. So if you, in the copy constructor, create a brand new piece of implicit heap dynamic variable or a new object or whatever, you get implicit heap dynamic variables, or it could be implicit heap dynamic memory, implicit heap dynamic object. You have to basically create a new implicit heap dynamic whatever you got in order for the new object to be pointing to a different piece of memory. So when you use a copy constructor, you're actually making a fake copy of the memory that the object is actually pointing to, so both objects aren't pointing to the same memory address. So is it really a copy? No, not really. You're making you're not copying it now. You're making a new piece of memory, so you have two different addresses, so both objects are pointing to two different addresses. That's implicit heap dynamic in by concept. So this question is talking about a variable, so that's even simpler. I just take a variable and I put it in a memory cell in the heap memory, and I have the object pointing to it. So what's the difference between that and dynamic type binding? Isn't it dynamically type bound? Yeah, It's the same. It's closely related. Well, implicit heap dynamic variables and creating those is just like doing dynamic type binding. It's just like Python. Python does that all the time because Python does dynamic type binding. So until you access it, and in dynamic type binding, until you access the variable dynamically and you bind it with a type, well, you have to go to the heap memory, see what's there, and access it directly, and then bind it with a type, and you're doing it during runtime. Well, that's the same thing you're doing with implicit heap dynamic variable. So to explain the relationship, well, it's the same thing. But don't just write, it's the same thing. Try to do a little bit of research on this one. You can do this. I'm not going to give you the research, but research implicit heap dynamic variables in the chapter or on the internet, and research dynamic type binding and see if you can tell the difference between the two of them. There's no difference. So you'll get tons of websites that will try to give you like fine-tuned differences between the two of them. They are close related. They are pretty much the same thing in the C language. The C language, the implicit heap dynamic concept is done through a copy constructor. It's also done, implicit heap dynamic deallocation is done through a destructor. You've got the copy constructor. You've got new and delete that does this. You have a lot of stuff. Well, actually, new and delete is explicit, not implicit. But you do have a couple of constructs in the language to do that, and they are creating dynamic type bindings. So up here before I told you that, C is 100% static. C++ with those objects gives you dynamic type binding. So you can achieve dynamic type binding in those objects in C++ by using explicit or implicit heap dynamic variables. So this is kind of a tricky question. You could put explicit here and it would actually be the same because C++ has to do things explicitly. And if you did explicit, that would be something like new and delete, because you're sticking explicit statements inside of the copy constructor, inside of the deconstructor. You're putting a, like delete this or new that. So anyway, I'll let you research that one a little bit more, but just know that there's not that much of a difference between the two of them. It's more of a semantic of how you're describing it. And to explain this relationship, there's not very much to explain. It's pretty much the same thing. So, all right, number 4. Describe a situation when history-sensitive variables in a program is useful. So what's history sensitivity? And we had this before the midterm, by the way, as well. History sensitivity means that the presence of the variable or the presence of the object or whatever hangs around longer than the instructions that worked with it, instructions that allocated it. So heap memory is history sensitive. When I allocate something to the heap, I can get back at it. We also have static non-heap memory that is history sensitive. For example, the array is history sensitive. And what happens when we send an array to a function? Well, there's history sensitivity, which means what happened in the function doesn't go away. So normally we have history insensitivity. Insensitivity is we forget about it. Oh, I don't know about the history. It's kind of like this current pandemic. We're all going to be history insensitive in a few more years from now. We're going to be, I don't even remember having to stay at home. That's insensitivity, which we don't care about. We just throw it away, forget the memory of it. We're not going to be sensitive about it. That's insensitive. And so normally functions are insensitive. And because they are insensitive, what happens in the function stays in the function. If you want to get it out of the function, you got to return it. So I'm talking about describing a situation. I'm going to talk about the use of a function, because functions are definitely a situation where history sensitivity matters and it's useful. And a variable in a subprogram, by the way, is a function. So subprograms in the C language, in the Java language, actually in Python as well, subprograms are implemented in the form of a function. So about 99.9% of all subprograms in all languages are functions. Okay, so When you want the data to change outside of the function, then you want to use history sensitivity. So history sensitivity in terms of a function means that you don't have to pass the information to the function and you don't have to return the information from the function. And because you don't have to do that, it's quicker. You just use a function. Now, I will tell you that Python has history-sensitive functions. I don't have to pass the data to the function, and I don't have to return the data from the function because I have a I have a global scope. So if I have A, and A is defined in my script or my program, and A is equal to 5, and I write a function, I can use A in the function without having to pass it in as a parameter to the function. And I can change the value of A, and I can exit the function, and I don't have to pass A out of the function. That is a situation when, excuse me, hold on, there we go. That is a situation when a history-sensitive variable is useful in a function. So describe a situation when a history-sensitive variable in a subprogram is useful. That's when I can change the value in the function and have it change outside of the function, and I don't have to pass it in and I don't have to pass it out. So that's actually one of the reasons why arrays in the C language are it's history sensitive. It's gonna keep track of what happened. So but there's still, which is odd in the C language, you still have to pass the array to the function. You don't have to pass it out, but you have to pass it in, which is funny. So if you could just leave it alone, like in Python, then you wouldn't have to pass it in and out. So situation is when you want to retain the value, which is a pretty easy answer to this question, but you want to describe it. When you want to retain, and so a situation when a history-sensitive variable in a subprogram is useful is when you want to have the data changed and you don't want to have to change it again when the function's over with. So if I've changed the value of a variable and the variable was an array or the variable was an int, it changed in the function, I don't have to pass it back. So it changes everywhere. So I can use the same variable in different functions in different places in the program, and they can change anywhere, and I have a global effect for it. The variable is changed everywhere. So it allows me to share data between different functions and between different parts of the program, and the data can be updated automatically without me having to manually update it. So this is one of the benefits of objects, actually, in object-oriented programming in C++, is that it's history sensitive. If I've changed something in the object and I use the object over here, and then I go over and I use the object over there in a different part of the program, it's changed over there too. I don't have to keep copying it back and forth all over the place. It's kind of like the difference between using a shared doc where you have multiple people, 5 people or so, editing a shared doc together and all the changes is merged together versus one person editing the doc and sending it to another person by email, then sending it to another person by email, then sending it to another person. What ends up happening, there's got multiple version copies of it, and it's labor intensive. Here you can just edit it all in one place. Same thing with a history sensitive variable. So go through, if you still don't understand it, go through the chapter and read a little bit more about history sensitive versus history insensitive. It's useful because it makes the program run faster because you don't have to keep copying it back and forth all over the place. Okay, last but not least, what is the general problem with static scoping? Well, that's actually what I just described in the history-sensitive variables. Static scoping is local scoping. In the C language, we have static scoping, local scoping. And the general problem with it is if you want to bring something into the scope, you have to copy it in. If you want to take something out of the scope, you have to pass it out. So the general problem with static scoping is constantly having to bring stuff in and constantly having to bring stuff out. So static scoping is when you have to pack a suitcase when you go on a trip because you don't have access to your clothes and to everything you have at home when you're traveling. Perhaps I shouldn't be mentioning traveling right now. Nobody can travel. But, one of these days we're going to get out of our stay-at-home situation and we're going to be able to travel again. And when we can travel, we have to pack a suitcase. Well, that's the general problem with static scoping. If our static scope is our house and we're going to leave our house, we got to bring stuff with us. And then we got to pack a suitcase. So in the C programming language, you got to pack a suitcase. They're called parameters. You got to send it over to the function. So whatever happened on the trip over in the function, if I want to bring something back, well, I got to pack it back in the suitcase and bring it back home with me, and then unpack my suitcase when I get back home. That's static scoping. That's the problem with static scoping. So C uses static scoping. Python does not use static scoping. Python uses dynamic scoping. So in Python, if I have something, I just write a variable. It's the same thing I was describing a few minutes ago. I don't have to pass the data to the function, and I don't have to return the data from the function. I can just manipulate the data in the function. So this would be like me going on a trip, not packing a suitcase, but then being able to somehow transport my clothes and stuff at home into my hotel room wherever I am. And so I can use the stuff at home, even though I'm not at home. That's dynamic scoping. So static scoping is limited. And the question is what's the general problem with it? Well, is the passing of the information back and forth. You don't have access to it everywhere. It's limited. So it's not part of the question, but I want to give you what's the advantage for it. Why did C do this? It's safer. I don't change the values of anything. So, for example, from a safety perspective, if I pack a suitcase, then all I have access to from my home environment is what's in the suitcase. And so there's no threat of anything else being changed outside of the contents of that suitcase or the contents of those parameters. So I can have a subprogram, I can go to it, and I can use it without having, to worry about damaging anything outside of it. That's what safety and reliability is about. Now it's static. So when I'm done with it, whatever happened to it. It's like, the trip to Vegas, whatever happened to Vegas, stayed in Vegas, that's static scoping. I don't bring it home with me. It's gone. But we all know that Vegas trips are not static. They're supposed to be static scoping, but they end up being dynamic scoping because you come home and then you read the Facebook page of your friends and they, somebody leaked it out. So that's dynamic scoping. Somebody leaked out what happened over there. So it's no longer static. It's dynamic. You might think of static scoping as closed or separated. Separated, segregated, closed off, not part of the real world. That's static scoping. The problem with it is if you want to bring something into it, you got to pass it in, pass it out. So you can use history sensitivity to get rid of the static scoping issue, by the way. So that's just a little added kind of tidbit I just throw in there. Just like the advantages. You don't have to talk about the advantages here. This is just the disadvantage, the general problem with it, which is why modern day languages are now using dynamic scoping. So in Java, Java uses history sensitivity to eliminate static scoping, by the way. Java as a programming language uses dynamic scoping just like Python uses dynamic scoping. So if I create an instance of an object and I have the object out there and the object sitting out there in memory, I don't have to create a new instance of that object every time I use it. If it's, for example, in the language of C, if I were to compile C, I would have iostream.h, let's just say, in the C, and for C in and C out. And each one of my programs that are statically scoped has a separate copy of iostream.h inside of it. So each program has its own copy of that library. And so the library is kind of set in stone and it's statically scoped. In Java, I have system.out, and that's in a separate library, and that's sitting out there. And all objects that are using this call to system.out are using the same object. We don't have to reinvent the wheel. We don't have to create a new object. We only have the library loaded one time, and all instances of all objects that are running out there in the memory are dynamically accessing the same library that's loaded. So in Java, you only load one of each library because you have dynamic scoping. And so you can see all libraries are visible to all other libraries and all other programs and things that are out there. And everybody can talk to each other. And it's achieved through history sensitivity. Once the object is loaded up into memory and it resides in memory, that object is available to all of the other objects that are also out there in memory. And it doesn't go away as soon as the object is over with. So if I have an object, it allocates another object, it's out there. Well, everybody else can see it too because it's history sensitive. So wrap up all those answers, put them into a Word file, send them to me by the due date for assignment number 6. I'm not going to say this, don't save it. Did I have it out there? I thought I had the syllabus out there, but let's just take a look real quick. As a refresher towards the end of this lecture, assignment number 6 is due on the 29th. This is the lecture for week 13, so it's due next week. You got plenty of time to finish assignment number 6 at this point. Start finishing those other assignments. I do mean it. I can't stress it enough. No assignments are going to be accepted past May 6th. So go ahead and use this week to catch up. So I hope you enjoyed the lecture and have a good rest of the week. And I will see you again for another video soon. Thanks for watching.